Hello guys, welcome to my channel Medicinal Pharma Education. I hope you're doing well and watching my videos. And I think so. We have completed the UV visible spectroscopy, we have completed the IR, and we have completed the spectrofluorometry. And today we are going to start the flame emission spectroscopy and atomic absorption spectroscopy. In today's class, we will discuss about the principle involved in flame emission spectroscopy, and we will discuss the instrumentation. In the next class, we will complete the flame emission spectroscopy by completion of interference and the applications involved in the flame emission spectroscopy. Okay guys, firstly we will discuss the important questions. What the important questions which are which may ask from this topic are: first, the instrumentation, the principle and the instrumentation, which is very important. And explain the principle and instrumentation and applications of atomic absorption spectroscopy, and explain the principle and instrumentation of flame emission spectroscopy. See, the main topics are only there are 4 topics involved here. The interference are not asked, but I suggest you to read the interference also, because in M pharmacy, right? In M pharmacy, in if you are in B pharmacy, it is you can just read principle and instrumentation application. In M pharmacy, what's happening, right? The examiner are asking the questions which are not asked in the previous paper. They are making the paper tough, as we have already studied in the UG classes, right? Means in the B form we have already studied, we know about the flame emission and everything, but the examiner is asking the questions which are not asked. So that I recommend you to complete the syllabus. You have to focus on every aspect of the syllabus, okay, to get a good marks. And you should not leave any question, right? So I better think that you should complete the portion itself, because in my exam semester, the different questions which are not repeated, they were asking, so that I just said you. Okay, next we'll just start with the introduction of the flame. We'll continue with the principle, method and instrumentation. Okay, first the flame. Flame emission spectroscopy is a method of chemical analysis that uses intensity of light emitted from the flame or spark at particular wavelength to determine the quantity of element in the sample. See, the principle of flame emission spectroscopy, as the name itself tells, is based upon the emission spectroscopy. Okay. Sorry guys, one second. It is based upon the emission spectroscopy. See, emission means what? When the light or energy absorbed by the molecule, if energy absorbed by the molecule is emitted out, okay, this energy is calculated to analyze to determine the sample. Okay, I think so I've understood the introduction of the flame emission spectroscopy. It tells that it uses intensity of light emitted from flame or spark at particular wavelength to determine the quantity of element in the sample. Okay, next, the intensity of radiation emitted by these excited atoms returning to the ground state provide the basic for analytical determination in flame emission spectroscopy. I already said, we have already discussed the emission spectroscopy in spectrofluorometry. The same topic is here you should apply. See, the intensity of radiation emitted by the excited atom. See, when the atom moves from the ground state to when the atom see, I'll just explain you the basics how the mechanism works. This is an atom. It absorbs the energy or light or radiation and present in ground state. After the absorption, it moves to the excited state where it is unstable. From the excited state, it comes back to the ground state by releasing the energy. Okay, by releasing the energy. This energy, how much it is released at particular wavelength, is used to determine the element. Okay, this is the basic principle involved in the flame emission spectroscopy. The wavelength of emitted light is specific is specific for every element. Okay. Next, a principle. Okay, the principle of flame photometry is based upon the measurement of the emitted light. See, I already said we have already discussed emitted light by the sample containing metal ions is introduced into the flame, and the heat excites the electrons on which energy to higher energy levels. Okay, see here what is happening, right? The when the sample is introduced into the flame, the heat or the heat from the flame excites the electrons to the higher energy levels. It is higher energy levels means excited state. Okay, as they excited as these excited electrons return to ground state, they release energy in the form of light. I already said you, right? They come back to the ground state by releasing the energy. Then the intensity of emitted light is related to the concentration of the element. As the intensity increases, concentration increases. As the intensity decreases, then the concentration decreases. It is directly proportional to each other. Method, the principle is given in a simple term. See, sample is introduced into the flame, then excitation occurs. Excitation means ground state to excitation state. Then excitation, after excitation, emission occurs, means the atom or ion or a molecule removes or emits out the energy absorbed. After emission, the emitted light is detected and then analyzed. This is the process involved in flame emission spectroscopy. I hope you have understood. Next, we will discuss the instrumentation. Okay, firstly, instrumentation. What are the instruments used? First, atomizer or nebulizer. Okay, burner, monochromator, grafting and prism. We are already discussed. I said you, right? If you read the UV visible spectroscopy, almost every monochromator, almost every detector, and almost every basic knowledge about the instrumentation will be cleared. So that I now also recommend you to complete the first UV visible spectroscopy. Okay, and amplifier and recorder. Okay, I'll just explain the instrumentation. You'll just you'll just understand the mechanism involved in flame emission spectroscopy. See, firstly, one side compressed air is passed through the nebulizer, and sample is also passed through the nebulizer. Nebulizer takes both and it sprays the liquid in the form of droplets, in the form of fine droplets. Okay, it has a narrow edge as the syringe. As a syringe, when we press the knob very hardly, as the liquid sparkles, like finely divided droplets sprays out from the syringe, right? Same mechanism is involved in the nebulizer. It will spray out. See, as the liquid is passed and the gas is passed through this, and a fine liquid is passed on the flame. This is the work of nebulizer. As the nebulizer, finely divided droplet falls on the flame. As the flame conducts the heat will excite the elements present in the sample. The excited elements emits the light back, and the monochromator at a particular wavelength selects the light and passes through the detector, and the detector detects the length or the wavelength, detects the wavelength. This is the main mechanism involved. We'll go through one by one. I think so you have understood. It is the main components are the nebulizer, burner, monochromator, detector, and amplifier and recorder. In every instrument, amplifier and recorder are present. Okay. Next, see, these are the 5 parts. First, the atomizer or nebulizer. Okay, what is atomizer or nebulizer? The name only says that it is converted, or it is the sample is sprayed into a finely divided droplets. See, the process of conversion of sample into a finely divided droplets using a jet of compressed gas. I already said you, right? Here we are using the compressed gas as a gas in a jet, in a uh, speed flowing vessel, a speed flowing cavity. It passes through the nebulizer, where the liquid also is present, and it carries the liquid through it, and with a narrow section, it's sprayed out in a high pressure, so as the sample converts into droplets, finely divided droplets. This is the main function of the nebulizer. Okay, next, there are mainly three types: pneumatic nebulizer, I think so I've pronounced it correctly. Next is the electrothermal vaporizer and ultrasound nebulizer. These are three types of the atomizer or nebulizer used. Okay, next we are going through the next instrument, burner is very important, as it provides the heat for the excitation of the elements present in the sample. See, it must have the ability to evaporate the liquid droplets from the sample solution and capacity to excite formed and cause them to emit radiation energy. I already said you right, the burner is used to excite the element or the excite the sample, okay, from to the ground state to the higher ground state to the excited state, where it emits back the radiation. Okay, where the energy or the radiation emitted back is used to detect or analyze the sample. There are mainly three types: total consumption burner, laminar flow burner, and shielded burner. The total consumption burner, this is the diagram. You can draw this diagram. I'll just explain you the diagram. See, one side the fluid or oxidant is passed and the sample is introduced in the between, as the flame also burns and the sample also burns. This causes the excitation as well as emission of the light, and the light or the energy emitted is passed through the detector by the help of monochromator, as we already discussed. See, here there is an monochromator which receives only specific wavelength and it sends to the detector. Okay, I hope you are. Next, the monochromators. I already said you right, monochromators are used to select the particular radiation or the particular wavelength to pass through it and allow the detector to detect it. Okay, they disperse radiation coming from the flame and falls on it. Okay, dispersed radiation goes through detector from the exit slit. Okay, from the dispersion radiation which goes dispersed radiation from the by the monochromator goes to the exit slit. Next, filters chosen has wavelength range transparent to emission from the elements of interest. See, what is the main function of filters? They select the particular wavelength range where only the element or the sample where the wavelength is tested only passes through it. Here we are using the grafting or the prism. You can just refer the UV spectroscopy. You can just or else I think so most of them are studied. You can just write on your own grafting and prism, because it becomes very hard to draw the diagrams and explain you again, because I'm referring like notes, right? I'm referring online notes and other notes to write these notes, and then I'm going to explain you, so that it's very hard for rewriting the diagrams or the explaining again and again. So you just understand my condition and just go and see the UV spectroscopy. Next, the detector. See, the detector, they measure intensity of radiation falling on it. Okay, here we are using two main detector. One is photo multiplier. Okay, I have not photo multiplier tube and photo emission tube. See, we have already discussed photo multiplier tube in UV spectroscopy. You can just go and see the photo multiplier diagram. Next, amplifier and readout devices. It's suitably amplifies and displays detector output. Okay, amplifier, what is the main meaning of amplifier? It amplifies means increases the signal from the detector. If the signal from the detector is very low, it increases the signal efficiency and it sends to the readout devices or the computer, where the computer tells the tester that this is the values of the sample given by the detector. This is the main instrumentation and the diagram of the instrumentation. I hope you have understood the diagram. Okay, and I'll just give you the notes. You can just write down flame emission. There are two main questions. Next, this is the flame emission spectroscopy. For now, I can't provide any notes for you through the link, but later on I'll just provide you the PDF of notes after creating my channel. For that, you must support me. At least if I get 1000 subscribers, I'll just create a website where I can post the notes. Guys, if you're watching, please subscribe. It makes my day pleasant. It takes hours to write these notes and explain it to you, because I have to read it first and then I have to explain it to you. Without reading, I can't explain it to you because it's not the ethics of mine. So please understand and subscribe and like and comment. Comment is very important because it makes my mood so pleasant to work very hard for you guys. Thank you guys for today's class. This class is over today. Thank you. Bye. See you in the next class. I hope you are liking my videos. Thank you for watching. Bye.